Yeah, at the end, we have been required to determine the sizes of three angles, alpha, beta, and theta. For those who just joined us, we have done part 1, 2, and 3, where we're looking at 3, 2, and 1. So you can check those videos. But then those who have been here, let's get straight to the point and then refer into the 2 million. Okay, what do we do here? We need to calculate these angles. So to calculate these angles, let's first just analyze the situation so that we don't end up wasting time. So look at theta. You can tell that this theta is actually going to be equal to this angle here. So you can also call that angle theta. And also, one other thing that you can maybe spot from the get-go is the fact that this alpha, it's actually going to be the sum of these two angles, because sum of the exterior angle of a triangle is actually equal to the sum of the two opposite interior angles. That's basically the reason that theta is equal to that theta, because this angle it's actually equal to theta because of vertically opposite angles. Okay, let's now just start with alpha, how we can try to do that so that we make some progress. How do we get alpha? Look at alpha. Alpha is basically the angle of inclination of this line. Which line am I talking about? I'm talking about this line. So as you can see, it's the angle from the positive x-axis up to the line. So from the positive axis all the way to the line. That is the angle alpha. And for us to get it, remember I said for us to get an angle of inclination for a negative or a line with a negative gradient, we need to first try to see if we can get this angle, which is the reference angle. So we're just going to do that. We're not changing the rules. So tan of the reference angle is actually going to be equals to the gradient of that line. I don't know what to call it, so I'm just going to say it's m. Okay, and then how do we get the gradient of this line? To get the gradient of this line, we have 2 points. Look at this point and also that point. We know their coordinates. This one, the coordinate is 0 and 6, and then this one, the coordinate is 4 and 0. Okay, so let's get the gradient and see how we can do that. We're just going to say 6 minus 0 divided by what is it, 0 minus 4. Then what do we get? We get negative 6 divided by 4, that's negative 3 over 2. Okay, that is the tan of the reference angle. Therefore the reference angle is going to be arctan of negative 3 over 2, if I'm not mistaken. And then what do we get when we punch this thing on a calculator, or we enter it on a calculator, or whichever English you prefer? It's fine, but then hey, if you pay too much of the school fees, it's not fine to just butcher this English language. Okay, you have that. Now how do you get alpha? Alpha is going to be equals to 180 degrees minus the absolute value of the reference angle, that is 56.31 degrees. Okay, now you just need to enter that on your calculator, and then you will see that this is the value that you get, 123.69 degrees. Okay, you are there. Worry not about this. Those who have been here, they know where it came from. Okay, and then let's look at B. Just gonna do it there. Okay, with B we are required to calculate size of beta. Beta is the angle of inclination of this line, as you can see. So to get the angle of inclination of that line, since it's slanted to the right, there's no need for our reference angle and stuff. So it's just going to be tan of that very beta equals to the gradient of that line. And then for that line we have 2 points also. Which points? You can think of this one and that one. So let's just write their coordinates. This for this point is 0 and 3. For that point is negative 3 and 0. So you're going to get the gradient of those 2 points. Okay, I hope you copied them. So to get the gradient, that's going to be 3 minus 0 divided by, that's the y. The x-axis is 0 minus negative 3. Okay, and then what do we have here? 3 and 3, that is 1. That is tan of beta, not beta. Okay, therefore beta is going to be arctan of 1, which is 45 degrees. That's your beta. And then let's try to do C and get done with this mess. See what's going on. We are required to get theta. Like I've already explained, beta plus theta, it's actually alpha, because alpha is an exterior angle of this triangle. You see that? So we can say beta plus theta equals to alpha. We already know what alpha and beta are. So to get theta, it's just alpha minus beta, which is therefore 123.69 degrees minus 45 degrees. That is equal to 78.69 degrees. Hey, so we'll be starting with circles, and then we keep it moving. Try to get done this analytical geometry so that we can do some serious stuff.